Hello, everybody. I think we should be good now. Unfortunately ran into a couple of issues with getting everything all reconfigured. So let me update these real quick. The next stream is not going to be today. That's today. The next stream is actually going to be next Monday, 7:10. Unfortunately, Wednesday, so in 2 days, we're not going to be streaming. I've got some other stuff going on. I am sorry that I started streaming just as you were going to bed. Hopefully I am not keeping you away from too much sleep. That would be bad. So where are we? I am going to SSH into this machine. 019? Does that sound right? That does sound right. There we go. So, let's see here. I think there's we should probably start this off with some announcements, I guess. The first major one is that I don't know how well this sounds because I haven't gotten a good chance to try and record in here yet, but I've now moved from where I was in a big open area to I've now got a nice little office area here, which I think it has a little bit better of acoustic. Thanks, cat. Come here. Unfortunately, the cat can still open the door and come in, but the upside is that no. The upside is that this space should be better for recording. Should have a little bit of better acoustics for it. And the upside is that I'll also be able to stream more. Now that I'm not causing the entire area to be quiet, I can do a little bit more streaming. So the plan is to do some less technical stuff. So putting things together and all that. So like when I've done, I guess you're just coming in, aren't you? Putting together like the overlays and things like that, doing video editing. But that's going to be in a different channel, and I will definitely say something on the Twitter before that all gets done. So that's that. The other big thing is that this Wednesday, so in 2 days, I will not be streaming. I'll unfortunately yet again be traveling when I would normally do a stream. So hopefully what we're going to do is we're going to get far enough today that we can have some good results for when we come back on Monday. With that said, let's move this around so that people can actually see. If we go on the Twitters, and I should actually pull this up so somebody can see this. This can go away. Oh, right, that's not me. This is me. This gentleman, Mr. Xavier Leroy. No, it's Xavier Leroy, I think is the right pronunciation. Was nice enough to give me a hand here. So he's one of the developers that actually, I don't know what his full-time job is, but he's an administrator on the ocaml list and helped a lot with the debugging here. He also posted this nice write-up. So this is the second write-up now, and I will post this in the chat if people want to read it. About what exactly they did with debugging it. And yeah, he has been involved with many ocaml bugs over the past 25 years. So he's been doing this development for quite a long time. But in any case, after the stream last Wednesday, I actually got a hold of this guy. I sent him an email. We went back and forth a little bit, and he was able to give me instructions on exactly what his setup looked like for him to reproduce it. I was then able to put that together, get it running, and was actually able to, and if we come back over here, I believe I was actually able to get that up and able to get a couple of seg faults. Just the one seg fault and a GPF, because unfortunately, their method for reproducing this is pretty difficult to work with. So I don't think he goes into too much detail here. But the short version is they have a ocaml they have some ocaml source code that when they compile it, actually, there's no reason for me to just explain this. I can show you. So over here, let's get screen all started up. That one. I really should get this set up to resize automatically for me, because I don't. So much of what I do is for these streams. Oh no, crap. Alias H focus. You can't see it. I'm using my hands to determine which way is left and right here. Alias left. What? I thought that was how I did that. I feel like I'm just being crazy here now, aren't I? I already thought I set these up. Oh, good. Sorry about this. Well, in any case, we'll just deal with this for a little bit. So, where were we? There's this report in the... I mean, you don't have to choose between them. I think the right answer is you can do both. You can even watch ads for both at the same time. But anyway, as far as this goes, there's this report in the... let's pull that up real quick, too. In the original... what I'm looking for, bug report of the ocaml stuff, which we looked at briefly, well, a little bit more than briefly last week. And did I forget to post the links for that? Okay. Yeah, so this is the original bug report. And if you come in here, there's this report.tar.xz file, which has the actual ocaml source code, which when you compile it, it does bad things. So we have that. Apparently what I was doing wrong when I was trying to reproduce this myself was the compiler version matters a lot. Apparently their specific examples don't trigger unless you're using GCC version 5.4, which just happens to be what ships with the Ubuntu LTS 1604, I think? Yes, 1604. So I wasn't having that set up properly, I guess, when I was trying to do this the first time, so I didn't get it to work, and the whole, like, ocaml stuff is scary and hard. But the good news is, all of this works now. So, if we come in here, I also received this right here, which is just because, you know, to make things convenient, a script to actually run this test case. So if we run this, what it's going to do is it's going to make some temporary directories. It's going to use task set like we were trying to do to bind it to one CPU. And then it's running the same ocaml compilation line as we were seeing before. The trick is, this one actually works because now I actually have the right environment for it. And I know that as soon as I say this now, it's not going to work. Because I need to come in here. Please still be logged in. Yes, I'm still logged in. I'm going to check this real quick, because the instructions are a little tricky here. I want this right here. I want to do opam switch 4.0 3.0. No. Okay, so now I should be able to do this right here. This should start up two processes. They're going to run for a little while, and at some point, they're going to cause a crash. At least that's the theory here. And I've actually had it happen before. Like we saw in the screenshot, I actually got it to crash, at least according to what's that thing? Dmessage. Because dmessage will report a very short line about any crashes you receive. So I was able to use that to realize that I had a crash. The problem here is, as you may be noticing, this is kind of slow. In fact, I think on average, when I was running this, it took me about a little over 10 minutes each to get a test case. So that's each time I ran this for 10 minutes, I got a crash. Which, I mean, you know, for something real, that's not too bad. The downside there is that 10 minutes is kind of a long time, especially because I want a bunch of these. And especially because they weren't set up so that I would get a whole bunch super easily. So, let's see here. Hopefully we'll get one of these pretty quickly. Nope, they went. So, when these succeed, when they successfully compile, we get this 1 OK or 5 OK message. We take a look at what this was actually doing here, right? While task set, they run this ocaml find, which honestly, I don't have the slightest clue what this line of code is doing. There's something about using like warn for strict to use threads, that you need the package extprot and to compile the test.ml file to output a test.cmx file. And then if that succeeds, we're going to print out OK. Otherwise, we're going to print out failed. Okay. That makes sense, I guess. Although, honestly, all the rest of that stuff is complete gibberish to me because I don't understand ocaml, and ocaml is scary, and I don't want to learn it. So yeah, if we let this run long enough, we should eventually get some seg faults. The catch here is that that's going to take a while, and I'm not sure any of us really want to sit around for like, we're going to sit here for 15 minutes, we might get a test case, we can then restart it and get another test case, and restart that and get another test case. So the first thing we're going to do tonight is we're going to put together a decent test harness for this. So rather than, this script is really good for what they were using it for. They wanted to know, did the thing we just try fix our bug? And this will tell you, you know, relatively quickly, did it fix it or not? Well, relatively being a kind of generous term here because it does take 10-15 minutes and it's not deterministic, so in order for them to determine that it was fixed and they could close their ticket, I think they said they ran this for 30-some hours and decided this, yay verily, this is done and we are good to go. Which is a lot. I don't want to do that. Well, I want to run this for 30-some hours. I don't want to have to manually restart this every time and deal with all of that. So what we're going to do is we're going to port this a little bit to make it a little bit easier to use. We're going to get things set up here so that I can gather core files and look at them a little bit easier. And then we're going to let this run a little bit, and hopefully that works well. That's what I'm thinking, at least. Although I want to let this run for a little bit longer, because I want to get the first of these and know how much I have to do for anything to work. So while we're waiting for this to run, like Jordan mentioned in the chat, currently the SGDQ is running, which if you're not aware of it is a lot of fun. So SGDQ is the Summer Games Done Quick, which is basically people play video games very, very quickly and talk about it as they do it. It's a lot of fun to watch even if you don't like the games, because these are people who really, really, really know a specific game really well. So for example, it is currently about 7:30 on Monday. So if you tuned in right now, somebody is trying to beat all of Sonic Colors with whatever the egg shuttle is in a little under an hour. We just missed Sonic Generations beating the game in just over an hour. These are a lot of fun. Like I had them on while I was working today. So like I watched this Spyro one where like somebody plays through the original one of the original PlayStation games in under an hour. The Ape Escape one here, they got a world record for. They're a lot of fun to watch if you want to see somebody who knows with incredible minutia something that honestly, very few other people in the world care about. So it's really interesting to watch. Some of these stuff tomorrow looks like a lot of fun. I'm pretty curious about these Tony Hawk ones. I played quite a bit of Tony Hawk when I was younger. I'm kind of curious about somebody beating literally that entire game in 20 minutes. That should be exciting. Other than that, like, they're doing this all week. Should be a lot of fun to watch. Definitely recommend it. Like, beating all of The Legend of Zelda with no sword in an hour. It's going to be exciting. And then there's some, like, really bizarre ones, like, beat Final Fantasy VII in 8 hours. That'll be exciting. Well, not exciting, because I'm not going to watch that, but... I guess that's enough of that. Would recommend, give it a shot if you're interested at all. Usually they're pretty good commentation and things like that. Plus, any donations go to charity. That's their big thing, is they do these twice a year. That gets donated. I know Doctors Without Borders is one of their big charities, things like that. So that worked, but unfortunately, we still don't have anything coming out of this. Oh, okay. Well, we didn't have anything, but we also didn't get an update yet, so that's not great. No, it's bind, not alias. Bind H focus left. Bind L focus right. So now I should be able to set this up in a screen RC so we don't have to deal with this every time. Bind H focus left. Bind L focus right. Basically what this is doing is this lets me use the H and L arrow keys to move left and right between these splits, like, you know, a normal person would if they used Vim a lot. So that's that. You're still running. Not quite sure why AS is running a whole bunch, but I can deal with that. Like I said, if we let this run long enough, eventually we're going to get a crash. So we're going to let that run while we come over here, and we're actually going to mess with this ourselves. So first things first, we're going to make a test.sh. We're going to call this a test harness.sh. And what do we need to do? So the first thing we notice here that needs to get fixed is this is hard-coded to use CPUs 1 and 5. Because, again, for the developers who are using this, they wanted to make sure this ran on their machine to reproduce a crash. They didn't want to optimize this to run on all of their cores as efficiently as possible, like I do. So the first thing we need to do is we need to actually fix this. And of course, I never remember how to do this properly. Bash shell script argument. So we're going to the Googles here. And the Google says we can just use the $1. So for this is where I'm curious if Jordan is still paying attention. So I believe I can do eval 1 plus 4, right? No. How do I add two numbers in Bash? Come on. Bash add two numbers. How do I add numbers? Okay, I can totally do that. So echo, oh, sorry, I should switch this over again so that you can actually see this. So if we do echo 1 plus 4, that looks good. So we want to do $1, $1 plus 4. So the reason we're doing this, right, is that we can call test harness with 0, 1, 2, or 3, and that will bind it to a specific core. That way we're able to start up several of these and have them all work. So we did that. Is there anything else we need to modify with this right now? I don't think so. But let's think about that for a minute. So the way this currently works is it splits it off twice, and it does that. But I think that's fine. If we want to be able to watch all of these, though, that's going to be a little difficult. I'm not quite sure what the best way to do that is. I think what we're going to end up doing is we're going to have this script like this. This accepts an argument. It will start up on one of 3 cores. We're then going to make just a simple Python script to manage a whole bunch of these, because I want to start up 3 of these on cores 1, 2, and 3. That way core 0 is left available for me to actually SSH in and do things. And other than that, I kind of want to leave this alone. So I think that's what I want to do. Is we're going to have that like this. That should work fine. Oop. Oh no, $1, $1 plus 4. So if we do this, cd, where were we? Report, or ocaml report, test harness, and we want to start this on core 2. Okay. That looked like it worked. Why did it fail to execute ocaml find? Failed to Oh, right. We need to do opam switch 4.03.0. And then we need to do... no, don't kill it. I want to select that. So we're going to come in here again. Test harness.sh. Oh, we still have this open. So we're going to go opam switch 4.03.0. Oh, and that. So we're going to switch into the right version of ocaml. And if we do this again, we should... oh. That's not good. I'm not thrilled that we have yet to get a repro. And that started it up right. We have 2 copies of test harness running, 2 copies of ocaml find running, and 2 copies of ocaml opt running. So if I do task set -p 2245, it is currently on 4. And 46 is on 40. Not sure if that's right or not. Okay. Oh. That looks right. Yeah. So the first time it was giving me the bit mask for it. What I really want is I want the CPU mask. That looks right. We're on CPUs 2 and 6, like we told it to be, and it's running. So that's basically doing what we want. Well, not doing everything that we want, because ideally this would be crashing right now if it was doing everything that we wanted. So that's that. We've now got it set up so that it will accept an argument of which core to run on. And what else do we need to do? We need to come over here again and core... what are these called? Core filters, right? This is not even close to being what I wanted. So there's all of these tricks, and they're not tricks. That's not what I want. Options that I can specify to make core files do something in particular. So, for example, I can say that this is not particularly nice, but like this page is formatted terribly. And let's actually pull this over so people can read this properly. So I want to set up my core so that I will have more information in it. I also want it to dump to a specific folder so that all of these will be in the same folder. So what do we want to do? I want to... So we're going to set it up. I probably want to do a dump the PID. That'd be good. It should be fine. Like just core.pid as the default, because unfortunately the Ubuntu default is not to do that. And if we come over here, we should be able to cat proc sys kernel core pattern and see that it is doing... What the hell is that doing? I don't want that at all. If you're running a Linux kernel that doesn't support this, you'll get no core files at all. This file, new in Linux 2.5, provides finer control over the form of a core file than the obsolete proc sys kernel core uses PID file described below. The name for a core file is controlled by defining a template in proc sys kernel core pattern. The template can contain that. Well, I guess we can just do this. Sudo echo 1 into slash proc, or let's not append that, slash proc sys kernel core uses PID. I said sudo. Let's type my password correctly. What? Okay. Echo 1 into slash proc sys kernel core uses PID. Exit this. Go over here. Vim test.c pound include standard io.h void main. What do we do? Car star a printf %s slash na. Right, this is totally going to cause a seg fault. Oh. Oops. I did an X there, I meant to do an S there. Right, so that segmentation fault. And if we do ulimit-c unlimited, oh, we need to remember to do that in our script too. We should get core.2411. It's not ideal, but this means that our core files will be unique. So we can let this run. We're just going to get a whole bunch of core files as we go, which will get us most of what we want. So let's go fix that real quick too. Slash ocaml report vim test harness.sh. Oh, it's still open. Did all that. We also want to do a ulimit-c unlimited. And if you're not aware, so the ulimit-c unlimited is just to actually start up our, is to tell the kernel that it should be creating core files, because Ubuntu by default does not create core files. So, I think that's what we want. That seems like the things we want. This is going to let us collect a whole bunch of these, which is basically what we want. But unfortunately, we still have yet to catch one of these. So one more thing we're going to do is we're going to run this again. Because it honestly doesn't, like, it doesn't really matter how many times you run this. We're binding this to a single core. Yeah, there we go. So the more of these we run, the more likely we are to cause problems. Yeah, see, we've got multiple seg faults now. Unfortunately, those are both at 0, which is a little less than ideal. They're also in libc, which, again, not quite ideal, but it's getting us someplace. So ideally what we want to do is now we want to do a kill all test harness.sh. Oh, that did not kill everything. That's unfortunate. Kill all test.sh. Yes. Ocaml find and ocaml opt.opt. 2, 6, 6. So we're going to do this again. We're going to start up a few of these and see if this might get us anywhere useful. So dmessage has yet to tell us we have a seg fault. Watch tail d. Oh, duh. Sorry, I'm being dumb about that, aren't I? I'm being dumb for several reasons here. The first of which is I should want to watch dmessage pipe to tail, like that. Also, those segments are from a.out, not our ocaml stuff, so that's why we weren't getting seg faults. Duh. But the good news is over here, like, we kind of expect to see some soon. Kind of. I don't know if that's actually going to happen or not, but I expect to see something soon. We'll see if it does or not. So that's running like that. Core/star. Oh, we did get a core. Interesting. So this gave us a core file. And how do I do this right? Man gdb/core. So I can do a -c core. 1/core. Interesting. Cannot. What? No, that's totally page memory. Yeah, like that is inside of your binary. Well, that's fine. I don't care too much. Because we want to ideally what we want to do is we want to find a whole bunch of these, not just find a couple of these. So that's set up. That's going to let us start finding some of these. Now the last thing we need to do is we want to write a py harness.py import subprocess. There's no good reason to do this in Python except that I actually know how to write Python, and bash scripting is not my strong suit at all. We're going to run this in a loop, and basically what we want to do is we want to, so while 1 for I in x range, so I want to do 1, 4, right? So I want 1, 2, and 3 to be the cores that we're going to run this on. We're going to do a subprocess dot, I need to look this up because the only subprocess that I ever remember how to do off the top of my head is check output, because that's the one that I use all the time. I want to do subprocess dot call. Run the command described by args. Wait for it. No, I do not want it. I do not want to wait for it to complete. Here, I can even switch this over so that we can actually see this together. Check output. I definitely don't want because I don't care about the output. You know, I can just use subprocess.popen, right? That should work fine. So if I do subprocess.popen, I want to do /test harness %s, comma, shell is equal to true. And we are specifying a format specifier of I. Right, so we're gonna run this 3 times, each time starting that up. And then I want to do import sleep, or not sleep, I want to do import time. I want to set auto indent because that's the only way I know how to write code. Time.sleep ox. So we said this is supposed to take about 10 minutes to repro. So 600 seconds would be 10 minutes. And then we want to do subprocess.check output, again, because that's the one I know. Kill all test harness .sh, and we should fix this up here. Subprocess.check output, kill all up. We need to do comma shell is equal to true here. Ocaml find shell is equal to true. And ocaml opt dot opt. Right? So this is going to start all of them up. It's going to actually run it, and then that's going to happen. Except, I'm also going to cheat a little bit. Like, I don't want just 2 of these running on each core. I want, how many is this? 10 of them. 10 of them running on each core. Python pyharness.py. Looks pretty sweet. This kind of looks like what I'm hoping to see, right? We should have PSAUX, like a lot of these running. It's a little disappointing that we don't have any crashing yet, but I seem to remember it taking a while to get real crashes. So PS grep ocaml find grep port count. That's not good. I expect to see more of those. I only have 3 of those running. Hmm. So I think what we need to do here is we need to actually create unique directories for each of these, which is going to be a little bit of a pain. Find dot dash name core. Okay. So that works. Well, I mean, we have 1 core dump. That's it right now. Oh, I'm sorry. I have had this on the wrong screen for quite a while, and nobody yelled at me. Oops. So we have this up and running. We have things going. But we're still not actually getting crashes. Well, we still haven't gotten a crash. We need to fix this. How do I do that? Can I get shell script get PID? So $$ is the current PID. Ooh. Oh, we got one. Look at that. So LL6 has a core dump in it. So that's what we expect to see, right? That this that we will eventually get this failed, and specifically we'll get ocaml.opt got signal and exited, which is basically just saying it got a signal. The signal is almost certainly a seg fault, and we'll get a core dump out of it and be awesome like that. But the other thing we want to do here is we want to make sure each of these has a unique directory. So in order to do that, we're going to come back in here. This is still open, isn't it? Ooh. That's one of those assembler messages that we read about. That, you know, there's all sorts of errors that come up with this because of how it works. That, you know, we're corrupting memory in a compiler. So all sorts of bizarre things happen. In this case, we're corrupting, I guess, like the input to the assembler somehow, which is bizarre, kind of awesome, but bizarre. So we have this. We want to do test harness.sh. It's still open over here, isn't it? So we don't want to just create this directory. $1 is the argument to this function. I want this to be, I'm blanking on how to do this. Dot dollar sign. This will work fine, won't it? Dot dollar sign. So we're going to go into, like, we're going to create a directory, which is the PID that we want. So if this all works, I should be able to do that. And I should now see 3.4. Yes, that is exactly what I want to see. So now each of these is going to have a unique directory to run into, which should ideally mean that a lot of this stuff is just going to work better. Kill this. PS kill all test harness.sh. Kill all ocaml opt.opt, and kill all ocaml find. Kill all sh. Kill all as. Okay, that looks better. So if we do this again, find dot dash name /. Yep, that looks like what we want to see. Let this run. So now we shouldn't get quite as many errors, because a lot of those errors were actually due to Okay, I mean, we can fix that too. PS. We're gonna do that one. That one. That one. PS. Good. So pi test harness.pi. We're actually just going to do time.sleep1. So this is going to take a little bit longer to actually start up, but it should actually work, which is, you know, what we want to get out of this anyway. Hopefully a second is long enough for the ocaml stuff to get set up. That's actually super exciting that we already got the first of our signals there. And again, for people that haven't been following a lot of these streams, the reason we're doing that every 10 minutes we're cleaning this up is just because we don't want to run into an issue where a long-running process causes the problem. We want to actually kill this and get it started over, rather than potentially deal with, like, oh, the reason this is crashing is because of something completely unrelated. So if we do a watch find dot dash name core that. See, we've already got one more new core. And ideally this is going to run, it's going to give us a whole bunch of new cores, and hopefully that's going to be something exciting. But, so that's running. Let's actually take a look at some of these while we're waiting. So if we come in here, I should be able to, that. So gdb-c 6.4941, the core file. I don't understand why that isn't giving me what I want, but SSH 168.0.19. Really need to get SSL private keys set up on this, or public keys, I guess. So I have to stop typing in my password. Downloads, the binary ninja. Ooh, we got another crash over here. Oh, right, I also need to start my X server. What is the downside to using the WSL, the Windows subsystem for Linux stuff, is that I have to manually start an X server if I want to do forwarding. Which, I mean, could definitely be worse. So that is that. So we want to find out what is at this instruction. We're going to come over here into our binary ninja. We said we were in ocaml opt, which I've already opened because I briefly took a look at some of these. Let's open this thing back up. Going to go. Ooh, It's still analyzing it. Okay, apparently I did not save off the analysis that I had. That's unfortunate. Oh, we got another one. Oh, we got another one. You guys can't see it because I've got the Fire Ninja up here, but no, I wanted to get rid of this one. We now have 1, 2, 3, 4 core files. It looks like 5 if we count the first one we had. So we should have quite a few now to actually go through and look at once we get through and do all this. I imagine the reason it's so slow here is because we're actually using all of our cores so that Binary Ninja can't take advantage of them on its own. It's going to be really awkward if Binary Ninja crashes now because it's trying to share a core. That's just what I want. I want my printer to start printing all on its own. That's exciting. I'm sure that's nothing dangerous. No one has ever, I don't know, connected to people's networks and made it their printers print out things. For people who aren't aware, that is something that I think Weave did. Scan the internet for a whole bunch of printers and printed out like swastikas or something. On all the ones he could find connected directly to the internet. Exciting things. Ooh. Fatal exception, invalid argument, string.blit divided by bytes.blitz underscore string. Huh. But yeah, now that we're running a whole bunch of these on 3 of our cores, that should work out fine. You know what? Now that I say this, I'm actually going to close Binary Ninja here. Task set -C0. I'm going to run on only 1 core, just to make sure. Like, I would really hate for our problem, like for us to run into problems because Binary Ninja is sharing a core and has its memory corrupted. Like, that'd be super awkward. Because if you're not aware, I'm actually running Binary Ninja on the machine that I'm doing all this on. Like, the test harness is actually, or the test system I'm using, I'm running the Binary Ninja from, rather than running it locally. That's mostly just because we were dealing with a whole bunch of compilation stuff. I didn't want to have to keep pulling binaries off and loading them when I can just set up X forwarding and it works just fine. Like, it's a little bit slower than I'd like, but I can live with that. I can live with my input being a little bit laggier than I would want it to be ideally. So, now we wait. And we wait. And we wait. And we wait. And kind of what I expect to see is sooner or later, because we're getting, I think, kind of close to the 10-minute mark, we should see all these say ocaml.opt got signal and exited when we shut everything down and restart it. I think we should be hitting that pretty soon now. In the meantime, we sit here and wait. Oh, you guys can't actually see that, can you? So the reason we're just sitting here and waiting is because Binary Ninja here is analyzing we're about, what, 11,000 of 16,000 functions. So I don't want to poke around at it too much while it's going. I doubt it'll be a problem, but you know, since we're already doing awful things on this computer, I would like to minimize the problems we can run into here. So let's see here. What else is going on that I can talk about while we're waiting here? So for people who are not aware, there are CTFs going on. So last week we had a CTF going on in which was SecuInside. I unfortunately did not get to play in it. I was busy all weekend and didn't get around to it, and the off time start didn't help with that. I had blocked out a little bit of time Friday night, and it turns out it didn't start till Saturday. However, PolyCTF starts this Friday, or Saturday, depending on your time zone. Which hopefully I get to play a little bit more of. I know one of the viewers here actually runs it. I don't remember who. I do know somebody was talking about how that was their CTF. They're running it. They're super excited about it. So that should be good. That starts this weekend, runs all weekend. Like, it's a nice, good 48-hour competition. I do think this is their first year running it, though. It's attached to Dimva, whatever that is. It's run by the Tower of Hanoi people. I mean, they're an old CTF team. They've been around forever, and looks like they've run this competition for a few years now. Oh, hopefully that didn't break anything. I accidentally yanked on the headphone cable I use here. Yeah, it should be exciting. Like, it's CTF run by a decent CTF team. That's basically all that I'm looking for in a good event. So that's that. Are we done yet? No, we found more functions. Okay. Let us wait for a couple more functions. How long have I been doing CTFs? So I started playing CTFs back in college, which would have been 2010, I think. I think this past year was my 7th DEF CON quals that I've played in now. So it's been many, many years of playing CTF. And when I say that, I should also point out that is many, many years of doing very badly at CTFs too. Oh, there we go. We are now completed. So yeah, I've been playing CTF for quite a while. And I find that, like, I know a lot of people get burned out over the time, and I tend to do that too. Like, I'll play, when I first started, I played really seriously for like a year and a half. It's basically like I went to work, I took classes, I played CTF. That's all I did. Well, and war games. Like, I remember the original like Smash the Stack stuff. Like, I'd get up at 6 a.m., go into work all day, go take my classes, get done with my classes, go home, go play Smash the Stack. And I did that for 2 or 3 months straight. And I had a complete blast at it. But then when I graduated and got a job, I stopped playing CTF. Things went on, and eventually I started playing CTF again. And that's how we ended up here, is after I started playing more CTF, it got more exciting, and we got into this. And with that story said, we just hit the 10-minute mark, and everything just restarted. So, if we come in here, we should see, where is this? 3? 4? Ooh. Well, this is a good way to see this. So we can see, like, we've got a whole bunch of different seg faults in a number of different IPs. That's interesting. We got, wow, this is a number of very interesting things. So this is dmessage that we've been watching here. Something about interrupt taking too long, which is bizarre and exciting. So one thing that has been thrown around and discussed about this bug is, can you use this to get kernel code execution? So with Rowhammer, which we don't know for sure yet or not, but both of those are, like, Rowhammer and this SKL 150 bug are both hardware bugs. In Rowhammer's case, it was like a physics thing about how transistors work, where this is a bug in what the CPU is doing. But they're both hardware bugs. So the question that comes up a lot is, I need to be able to execute very, very, very specific things in order to trigger this bug. Like, this bug existed for a year and a half before anybody even tracked down what was going on with it. So it's very uncommon for this to happen in places where you don't have direct control of the processor. But that's still pretty interesting if you can trigger this to somehow get kernel code execution. So if I can, write some code, run it as an unprivileged user, and cause that to give me code execution in the kernel, that's still super interesting. Not as interesting as if, like, I can trigger it remotely and get code execution in the kernel, but it's still super interesting. No, I did not use a Binary Ninja plugin. I'm just running it straight out of the box. Ocaml is compiled with debug symbols, I believe, and that's it. They actually just identified all these symbols based off of what is in the binary. I didn't have to do anything special here. So, in any case, this right here is super exciting. This is also a little exciting. Hitting invalid opcodes is usually a sign of bad things happening. Maybe this is like we got, like, it's entirely possible we got control of PC right here, and it jumped to a misaligned instruction, or something like that. But super exciting. Means that the, like, number of different seg faults we have listed here kind of indicates to me that hopefully this is going to be exploitable. So, where were we? We had that. Let's take a look at this crash. So we want to go to this address, and if we come back over here, we now have Binary Ninja up with stuff relatively identified. Ooh, man, the processor is not happy. I guess we're also using a ton of memory, aren't we? Might be using more memory than I actually have. So, come on. We'll get you there. You can do it! Maybe trying to do all this at once wasn't the best idea. I was hoping that if everything was bound to... So everything is bound to processors 1, 2, and 3, and Binary Ninja is bound to processor 0. So at least my thought was that this should be pretty straightforward to do. Apparently, that is not exactly the truths. Okay, so I think what we're going to do here is we're going to come in here. Nope, that can go away. This can go away. We're actually going to kill this. So, while I would like to have all of this working, I would rather have ocaml find ocaml opt.opt. Like, I'd like to have this running as we go, but would much rather have the ability to look at these right now. We get these started again, and I can let these run, and, you know, come back on next Monday and have, you know, hundreds of these to look at. So, we have this. We should make this a function. Because it's a function. Make this a function. Okay, we're gonna kill this. Bye, Binary Ninja. Save it, yes. We want to save this. Sure, save it there. That database is huge, jeez. I've actually never seen that pop up about a, having to save the database. I guess that's a, sign of just how big ocaml is. Or a sign of how, you know, CPU bound our processor currently is. So if we go here, we're gonna go to where this is. So we crashed here. If we make this a function, what do we get? So we were reading from RAX when this crashed. That is beautiful too. We read from RAX into EAX. Oh, I guess that's not quite as interesting. I was hoping, I misread that, and I thought it said it read from RAX into EAX, it then it dereferenced that again, and then called a function. So it's not quite as exciting as I was hoping it was, but... Ooh. Huh. Well, that clearly is not a good memory address that we are trying to read from. All right, so we're oh, sorry, you guys can't see that. So we're trying to read from, like, a negative value here, which is clearly wrong. Like, there's no way that would ever work. Let's take a look at some of these other ones. Find dot dash name core. GDB 1.4842 core. Oh, I want to do GDB-C. I forget that because I very rarely actually use the C flag. So this one is at OX4829A7. This is reading from RBX, and it's going to call ocaml int compare. And RBX is... Oh, I keep forgetting to switch back and forth through this. So this is reading from... like, somehow RBX, which is an argument to this function, is being read from and is just straight up completely wrong. Do we get a backtrace here by any chance? Ooh, we do get a backtrace. Oh, that's a really big backtrace. I guess that makes sense that it's going to be a big backtrace, but unfortunately it's more backtrace than I really want to dig through. What else do we have? So we look at the first of these. GDB-C 1.4821 core. And this is in that. So this one, we are reading from RDI when we get our segfault, which, how did you get populated? RDI was RAX when we started this function. So this is wrong for a number of reasons. The first of which is RDI is clearly not in mapped memory, which is why we got a segfault. RAX is also pretty clearly not in mapped memory. So how did that happen? So this is in some sort of like list. So this is in a, if we take a look at this, cam list rev append, whatever that means. And this is also dealing with their garbage collection code, which is kind of what we expect to see, right? Based on the bug reports, we know that sorry, I'm blanking on this. Bug reports indicate that this is all related to garbage collection, at least in the cases that we have. That somehow, when the garbage collector runs, we know that sweep slice uses the AH register and the RAX register, which triggers part of the bug that we have. What we're looking for here is what do we need to do to trigger the other part of it? Because we wrote code last Monday, which would, well, Monday and Wednesday. The first time was really simple code to use AH and RAX. Then last Wednesday, we wrote some more complex code to use both of them, with the idea that by having, like, we were able to pretty tightly control, like, what RAX and AH were doing. And it looked pretty similar to what sweep slice was doing. We still weren't triggering it. So what we need to do is figure out what the other thread needs to do. Because clearly, in the case where we were trying to reproduce it, we were getting our thread to do hopefully the right thing, but we weren't getting the other thread to do the right thing. So what do we do now? Well, the first thing we do here is we're going to track down a bunch of these core files. So there's this one, which, I mean, it doesn't seem super interesting. Especially since we're only getting one of the threads for this. That's actually kind of awkward. Because of how these crashes happen, it means that we only get one crash, or one side of the crash. Ooh, this is a sigil. Sigils are exciting for a number of reasons. Mostly that I really hope this is true. Oh no, that's a real illegal instruction. So this is super exciting, right? We somehow managed to get ourselves, like, FFFF is not a valid instruction, right? Of course you can't. Actually, can I do that by going... So this is .opam 4.03 bin ocaml opt.opt. Oop. There we go. Ooh, this even tells us where we are. There we go. Look at that. Now we can actually read some code from inside our G. We probably want to do set disassembly flavor intel. -1. That's not right. -2. 3. That looks like it might be a real instruction now. So what we did here, right, is we stepped backwards a few instructions till we got something that looks like real disassembly. So what we did is we somehow managed to jump. So we have our PC here is 42E55C. So we jumped in here somehow, which we shouldn't have done, which is in the middle of this jump instruction. So do we have a backtrace? Oh, we have a backtrace. That's the best. Okay. Well, it's not quite the best because this backtrace is kind of big and confusing, but what on earth were you doing before we got here? And the answer is... But that's not how a backtrace is supposed to work. Why is this the start of a function? I mean, I guess that's a thing that can happen. So we're in camel compare. We walk farther back here. We have so iproc mapping. So we know that actually, can I just do this? Do have the libraries for it. Look at that. It's crazy how computers work when you actually have the proper libraries for it, for stuff. That is not correct at all. This is very much less than ideal. So our backtrace says quite a lot of stuff. And I'd like to believe it, but this is clearly wrong. So to start with, we are in fact executing an invalid, like PC currently points at an invalid instruction, which is awesome. That's what we want to see here. However, this is not a return address. This is not a return address. This is probably not a return address. We can verify that real quick. Yeah, that's a null byte. So I know from many, oh, that's not a null byte. I mean, it's close to a null byte. Like, this is clearly wrong. Like, all of this backtrace looks wrong. Actually, is that just our stack? RSP, no, that's not just our stack, but what is that? Like, that's not metadata that I know what it is. So iproc mappings. We are in 7F29D129. What? That's not any of the maps that we have here. That's definitely interesting. Especially given that we can actually read from it, which is kind of bizarre. Like, I have no idea what this data is. It's some sort of a data structure. It's got pointers in it. It looks similar to the stack, right? So if I dump a whole bunch of stuff out of our stack, it looks kind of similar, except that's just a whole bunch of pointers too. RSP minus OF. Come on, I need to type better. I've got no idea what this stuff on our stack is. So what we're looking for here is we should see an occurrence of... Oh, let's do it this way, can't we? What does RBP look like? I mean, RBP looks also bizarre. And eventually we get some stack pointers down there. So, what's this thing? We're gonna come back over here. That, I will believe, is a saved PC. Which raises the next question. So call RDI clearly did not get us to where we wanted to be. So what did it do? So RDI, and if we switch back over here, RDI doesn't look like, that does not look like it's currently a function. In fact, that doesn't look like it's even close to being a function. Well, actually, could we execute that? So what I'm curious about here is, could we get far enough down here that it would eventually... No. So how did we get here? That's the question, right? But RBX. Okay. What is that? That also doesn't look right. I mean, that looks right-ish. I mean, I don't know what the internals of the ocaml compiler are doing, but it means that it's not what I'm guessing is our saved RBP put there. So let's think this through. If we come up here, we have this right here. And we said that this... Where am I? How did I get here? This looks like a saved PC. And if we look over in what they were doing here. Hello, David. We currently have a... So we currently got the ocaml test harness stuff working. We have a whole bunch of core files now, and we're actually taking a look at what some of these look like. This one in particular, it looks like we corrupted the low byte of PC. I don't know how, but it looks like we somehow managed to do that because we're getting an invalid instruction on this one. So we're trying to dig in a little bit more about what exactly happened here. So if I'm not crazy here, we should see if we said this right here was our saved PC, then we should be able to say RSP plus 40 hex would be our RBX that we read from, right? RBP plus OX40 plus some change means that, so we were here, So I believe that that means that should be it, right? If my math is correct. Well, that's clearly wrong. This is also not it. That's not it. Like, none of these are pointers to... Well, they do reference it. Yeah, none of these are pointers to pointers. That might be a pointer to pointer. It is, but it's also not even close to being what we want. So we're stuck in an awkward position here, right? This core dump looks interesting because we ended up getting some, like, we're pretty sure in this one we got control of PC. But we don't know how memory got corrupted. I don't know a good way to test that. So we're getting to the point where now we can create some core dumps and we can figure some stuff out from that. And I think the best thing to do right now is to actually call it an evening, let these run, gather a whole bunch of core dumps over the next week, and actually do some analysis of, do we end up in the same position a lot? Do like some frequency analysis type stuff. So if there are certain PCs that are much more likely to come up, we're going to take a much better look at that. What was the compiler agnostic function detection plugin? I don't have the slightest clue. I don't know what that is. Compiler agnostic function detection sounds very, very hard and something academics would do, and I would run and not really understand what they're doing. So if you know what that is, I'd definitely be interested in taking a look at it. But as far as this stuff goes, I think the plan right now is going to be we're going to let this run all weekend and hopefully get a ton of core dumps out of it. Because ideally, if we have, 1,000 or 10,000 core dumps, we'll be able to go through and figure out, oh, this core dump, like these 100 core dumps all have the same PC, so that PC must be doing something interesting, as opposed to, oh, something got corrupted nearby. And at least the thought here is if we do that enough, we should be able to get a good idea of, okay, all of these core dumps ended up being nearby each other. So something like what this area of code is doing must be what's important. And hopefully we're going to be able to take that and turn that into something like useful conclusions. Useful there would be in very, very big quotes, because we still don't actually know how to trigger this entirely. We have an idea of how to trigger one of the threads to get it there. And that's about it right now. So, with that said, I think it's about all for tonight. Unfortunately, we didn't get a ton of progress. We did get to the point where we have a test harness running, and I'm going to be able to let this run all weekend. If anybody's interested in it, I posted a link to the Xavier blog post about this. So there's now been 2 different ocaml developers who've posted their write-ups on trying to find it. They're all interesting. I haven't actually read through them with a ton of detail, because skimming through it, while it's a lot of really interesting details about debugging a very hard problem, most of what I've been looking for up to this point is how do I reproduce this? How do I reproduce this? How do I reproduce this? And none of these actually had that. But I do recommend it. It's pretty interesting. One thing that I find particularly interesting about this one is, let's move this so I can actually show it on the stream properly, is this little bit right here. That ocaml in particular seems to be hitting quite hard by this. I don't know. Oh, duh. ocaml in particular seems to be getting hit quite hard by this. I don't know why. All I know is that, for whatever reason, the ocaml garbage collector is emitting code that this matters for. So hopefully, when we can isolate what this is, we'll be able to figure out a little bit better what the other threads are doing that causes this problem. Because at this point, I'm pretty convinced that we need to get like the branch predictor in a certain state, and then make our threads do stuff, not just get our threads doing stuff. So we'll see. I'm hoping if I collect many core dumps, that will be sufficient for us to have some big revelation about what's going on. So other than that, thanks everybody for tuning in this week. Sorry about the little bit of a late start. Like I said, I had to rewire a whole bunch of stuff because after I moved, it didn't work out quite the way that I wanted it to. And also, keep in mind, this Wednesday I will not be streaming. I am once again traveling and will not be able to have a stream while I'm on the road again. So next Monday will be the next stream, and hopefully at that point we will have many core dumps to go through. At least my expectation is that there will be plenty to go through, because I'm going to leave this running all weekend. Hopefully by the time I come back, I'll be able to rip it open and see, oh, I have, 10,000 core dumps we can analyze on Monday. At least it's a plan now. Other than that, hopefully everybody has a good weekend. I will throw it out there one more time that PolyCTF is going on this weekend. At least one of the guys who, or gals, I'm not sure, who watches this stream is a developer for it, or somehow attached to the organizers. And for that reason alone, I definitely recommend giving it a try. So thanks again, everybody, for tuning in, and I will see you all in about a week. Bye.